recording. Start recording. Hello everyone, welcome to Handmade Hero, the show where we code a complete game from scratch. Absolutely everything is on the stream. There's no hidden secret things I do while people aren't watching. And we basically use no engine, no libraries, no nothing here. Just straight up C++ compiler. And currently we use the C runtime library, but we're thinking that probably eventually we'll get rid of even that by the end. So we're trying very hard to basically show absolutely everything that happens in the execution of a game, so that literally every last little thing that goes into making a game run, we explore on the stream, explain how it works, show how it's developed, and kind of give insight into why it's important, why that piece does what it does the way that it does, so that you can really come away with a complete understanding of everything that happens when a game runs on a computer. And I guess on a console for that matter too. They're not that different. There's some nice things about consoles you don't get on PCs, where you kind of know the hardware a little bit better because there's a very specific set of it. But on the whole, they're not that different these days. They're very, very similar. Used to be the case that consoles were very different from PCs. Not anymore. They're basically just little PCs in a box. Anyway, if you have pre-ordered the game on handmadehero.org, you can download the source code. You should have gotten a link in your email that allows you to do that. And if you would like to follow along with today's coding, what you can do is you can go unpack day 60, because we are on day 61 right now. So just unpack day 60's source code from the source code zip file. It's like the zip file that you download has just everyday zip just sitting in there. So you can grab that one out, unpack it, and you will be exactly where I am today. So that is that. Let's go ahead and get started with the coding. Right now where we're at is we are trying to go through and make essentially what is sort of a placeholder version of the game. Something that just has a little bit of everything so that we can see the sorts of structure that emerges in the code, and that is what we will be basing our actual industrial strength engine code around. So we've basically done little dummy implementations of everything, which are okay but not great, and they're just there to get something in quickly that we're able to sort of test with and see the structure of. Now what I did before on the stream, just before, I guess it would have been Friday morning, was I added hit points, and you can see that now we draw some little hit points below the guy. He's got 3 little hit points there. We also have this little familiar who follows him around. And then we have this little, we just used the torso from the guy to draw as a little monster that's sitting there. And so what we kind of wanted to do now is just get some monster activity in. So we kind of wanted to make it so that this monster could somehow maybe follow the player a little bit, maybe attack the player a little bit, and maybe we'll give the monster some hit points as well, and then allow it so that the monster and the hero can sort of trade damage in some reasonable way. Again, just so we can sort of build up an understanding in code of what the sorts of operations are and how they have to occur, so that when we start building the systems for real, we will not make sort of the obvious mistakes that a lot of people make when they start trying to write systems without any knowledge of the things that need to run on those systems. That's a very common mistake, not just for amateurs, but also for professional programmers. A lot of times they will make the mistake of writing a system before they actually know how that system should be used, and that's a really big mistake. So I always say write the usage code first, and that's exactly what we're doing. We are basically making a bunch of synthetic usage code so we can see what we need to do. So right now we don't really have any even way to attack. We do have a way to jump for no real reason. So what I think I might do is go ahead and replace that. I'm going to move that jump over to the spacebar, and I'm going to go ahead and bind the arrow keys over to just something simple, like maybe a standard 4-way shooting kind of a thing, just something where I can attack basically in a direction, right? Maybe something where I can just attack in a direction by pushing one of the keys. And then we will see, when I do an attack in a particular direction, I want to make it so that I can count the fact that if that hit a monster that's in the area and take away hit points from that monster, if so. So I want to do that, and in order to do that, I would also have to give our little torso monster there a hit points himself, because he would need something to decrement from. So that seems like the most straightforward thing to continue with as we go. So I'm going to go ahead and get that going. So if I want to add hit points to the monster, what I would need to do, well, of course, one thing I need to do is open the editor, to say the least. So what I would need to do here is I need to make sure that the monster can have hit points just like the hero can. And so right now we haven't split out our entity data. We just have all the entity data in one place, which basically means that, you know, there already is the concept of hit points in every entity right now, which again is something that I at least suspect we will actually not want to do in the final entity system. But for now, that's, you know, we're just putting things in here so that we can see how they work. So that means everyone already actually does technically have hit points. We just need to initialize them to something at the start, and then we need to draw them, right? So what we need to do here is we need to go down to the hit points, and we need to see those are actually getting drawn when we draw our player, right? Here's the hero drawing code. Here's the code that draws the hit points. That won't really be any different, and we don't really want it to be different. Presumably, we want to draw hit points basically with the same code, no matter whose they are, and then we just tweak some parameters, like maybe what color they are or something like that. But for the most part, we don't want to redo the logic. So no matter how we end up drawing hit points, I think we're going to want that shared. So basically what I'd say here is we want something like draw hit points, right, that we can just call on this guy. And that's just going to be this code here. That way, when we go down to the Monstar, we can draw hit points on the Monstar, and the Monstar will have them as well. So I'm going to go up here and just put that code in there. And I'm going to have this be called draw hit points, like so. And I'm going to just pull that out. Now I need to call it multiple times, and we just need to see what the stuff is I actually need it to do. So if you look here, there's not a whole lot to it. Basically, we've got that low entity. So we have something here where we want to do the low entity. It wants access to that. When it's doing this positioning here, it looks like it wants a piece group, right? It wants to be able to draw the things onto one of these piece groups. So let's go ahead and make sure that it has one of those as well. That's where it's going to put its drawing information, like so. And then looks like we just need, really that's about it. We just need an X coordinate for where these things are being drawn, and I think that's just about it. And in fact, I guess the piece group kind of takes care of that. Let's see here. Does that really all we need? What else do we need? Push rect entity piece group, right? So that doesn't take an address, but that's it. That was all we needed. So I guess we really don't have much work to do to move that out. That was really pretty trivial. So now our Monstar can have them as well. And if our Monstar is going to have them, we need to initialize those hit points to something, because right here you can see that we've got those. And so when we add our Monstar, I'm again going to just pull out the code there, which is something like init hit points. And then we'll just say for now that you say the hit point count, you know, however many you actually wanted in there. And that will just do this code right here. So we'll pull that out like so. And we'll go ahead and say that we do init hit points. And we pass that entity low, which is all it should really need. And then how many hit points we want, which in that case was 3. And I guess for the Monstar can also have 3. Why not? So when we do this right here, we will then have the low entity, which we have, entity low, and that will go ahead and set it to the hit point count. We will want to assert, obviously, because we don't really have much in the way of flexibility here yet, just to make sure that the hit point array can actually store the number of hit points that it's asking us to do, because we're storing actual data with each hit point, so each individual like heart essentially on the person can have potentially property associated with them. We're not sure where that's going quite yet. Those might be entities themselves in the future. We don't know. So we kind of have a simpler system at the moment, but we may kind of ratchet that up a little bit. We'll see. So anyway, we now have a situation where we've got the hit points, and we need to initialize them all. So I'm going to go ahead here and do a hit point initialization loop where I just say for every hit point that we have here, that's basically the max hit point count is giving me that information. I'm going to go ahead and set that filled amount equal to something reasonable. All right, so we also need, let's see, hit point equals entity low hit point plus hit point index, like so. And then that hit point is just going to be flags. There are no flags on this one, and the filled amount equals fully filled, essentially. So that's that. And so that will initialize our hit points. And so now let's see if we actually get, yes. So now we have monsters, Monstar. Our Monstar and our hero both have hit points now. Our familiar doesn't because we decided, or we didn't directly decide, but we didn't go and add them to him, which I don't know if the familiars will have them or not. Possibly some will, some won't. We don't know. But now let's go ahead and make it so that we can attack our Monstar and eventually kill our Monstar as well. I think we probably want to be able to kill our Monstar. So let's do that. So if we're going to attack, we're going to need some way of attacking. And I don't know if I actually put in anything. I don't think I have any real sprites in here yet that would be related to this. Let's see what's in here. In the Handmade data, oops, that's the code directory. Handmade data directory. Of course, we know that Windows is bad at actually being able to display these, but we should be able to sort of see what they are anyway, even though its display is messed up. So there's a little boulder thing. I could use that as a projectile. It's a bit large, to say the least. What have I got in here? I don't think I have anything particularly good in here either. Yeah. Yeah. Not a whole lot I can use. So maybe that boulder is going to have to be it. So let's go ahead and pick that one out. Whatever is the smallest one. I think that's probably the smallest one. Rock 03. So we'll just basically say that that is kind of going to be our attack region. And so I want to make this, I want to basically say for now, let's stick with the Zelda-y style of, and I know that originally in Zelda you had two different cases. If you were full on hearts, it sent a projectile out, and if you weren't, it didn't. But let's go ahead and say for now, like we're just going to do essentially something that's like a sword swing. So we want something that is going to come, be a hit region that lasts for a brief amount of time next to the player. Anything that gets touched by that is considered hit and takes some damage, but it doesn't really do anything, beyond that. So there's a lot of ways we could implement that. And it's not necessarily immediately clear how we want to do that. It is a little bit confusing, right? Because there's many, many ways we could do it. One way we could do it is to have that actually be a special state that occurs where someone is striking and we know that that's the case and we actually have code specifically to check for it. Another way to do it is to have it so that it's basically piggybacked on top of an entity. So there actually is sort of a sword entity. That sword entity only comes out during the strike. And during the strike, if that entity collides with other entities, then we know that it has hit them, right? So that, I think, is where I'd like to go with it. I'd basically like to make it so that, let's see here. I don't actually know how to do zoom in and out very well. All right, there we go. There is zoom in and out. So what I decided to do, by the way, is I decided to start just saving these into the Handmade Hero directory. So from now on, we should actually be in a situation where all of the drawings from now on are actually saved. And if you have Mischief or use the trial version, I think there's a trial version, free version or something. In fact, no, there is actually a full free version. If you have the free version, you can actually go and do it. So from now on, what I'm going to do is I'm just going to take a look at the day number down here, and I'll actually just kind of do like a day 61 landmark up here, and then so I'll try to draw kind of down inside this, and then I'll move over as we go. So that way when you load it up, you can go look at the drawings if people want to. I don't know if they do or not, but just in case, since it's now with Mischief, it's easy for us to do that, I'll just do that. So here's mainly the problem. What I was just saying is relatively straightforward, right? I've got a hero entity, right? Here's my hero entity. And if I had some other entity that was just generally not visible, that's my sword strike entity, and when when you do the sword strike, the sword comes out here, and then anything that touches it takes damage, that's actually relatively easy to implement with what we already have, because we already have the ability to tell when things touch other things, obviously. But there is a kind of unusual circumstance that we have here, which is something that we hadn't addressed yet, right? Which is that the sword entity, let's say that there is a Monstar, right? So there's a Monstar here, right? This is Monstar. Let me actually draw that a little clearer. So this is Monstar, right? So if Monstar is touching the sword, our collision routine that we already have will be able to tell us that Monstar is touching the sword. That's not actually a difficult thing for us to do, because we already have collision code that will tell us that. The problem is, if this sword strike lasts some number of frames, like let's say that the sword lasts 10 frames, right? So you push it and it's out there for 10 frames. If that's the case, we will find that we will get 10 frames worth of strike evaluations, right? So what we need to be able to do is we need to be able to have some conception of the fact that only the first time that this sword touches someone on that strike do you actually get it counted as a hit. Because otherwise, it would actually go ahead and take 10 hearts off a guy whenever they were hit, because on each frame it would go, oh, the sword is touching the Monstar, so -1 hearts on the Monstar, and then the next frame it would do it again, and it would do it again, and it would do it again, right? And so for however many frames the sword strike was visible, that's how many hearts it would take off. So what we need to do instead is we need to have some kind of a concept, right, which we haven't really done anything to deal with yet, of the initiation of a collision as opposed to the maintenance of a collision, right? So we need to basically know, is this collision, right, new? And we need to know whether it's new, because if it's not new, then we don't want to actually process that stuff. So there's a couple ways that we might want to think about doing that for the sword. One way we could do it, which is kind of the realistic way a sword would work in some way, is actually problematic for us. And I'll tell you why in a second. But what that basically would be is you test to see whether the sword and the monster overlap initially versus whether the sword and the monster overlap as a result of whatever happened on the frame. So on the first frame, when a sword strike occurs, you note the fact that the sword was not even on the screen at first, and then it is now, so all collisions are new. On the frame after that, you go, okay, the sword was on the screen initially, so check who it was touching, and then after we do our movement update for that frame, see who it's touching now, and anyone who it is newly touching, who it wasn't touching before, count the strike for them, right? But we really don't, and that's like just more of a like, oh, I'm actually like pushing a sword into somebody kind of a thing. I don't really think we want to do that, because you get into like weird cheating scenarios where you can kind of oscillate on the Monstar. Like if you can move it back and forth a little, you could hit the Monstar multiple times. So I think gamey wise, the actual metric for whether you hit someone with a sword is really pretty straightforward. It's basically like on the initial frame, right? Wow, that's some bad handwriting. On the initial frame is actually what we're talking about here. On the first frame that the sword is, where the sword strike is initiated, things that are touched on that frame by the sword take damage. Things that aren't, right? That would be how we would do it, right? Now, just because I want to continue down this path of why this is kind of complicated and warrants thinking about. So this is for a stationary sword, right? So this right here is all if the sword was stationary, right? So this is like a stationary sword. Now let's think about what has to happen if the sword is moving, right? So this is a flying sword. Okay? Now we have an even harder problem. Because now, if here is my hero, right, and here comes the sword that he comes out, the sword is actually traveling in this direction. So it's a given that the sword is going to go through some number of Monstars on the way, right? Could be 0 if it was just a bad shot, but it could be maybe 2 or more, right? And, you know, we could cheese out and say as soon as the sword hits somebody, the sword disappears or something, like it's a one-shot sword. But that should be a game design decision. We don't want to do that just because our algorithm is lousy. We would like the game to be able to have, for example, different types of swords. Some that have piercing would be what this would be called, right? And so what we'd like to do is allow the sword entity to travel in a line, and whenever it hits a monster, we would like it to do damage to that monster only once, right? That's what we would like. And unfortunately, I can't say I know any solution to this problem that does not involve actually just tracking the information. I don't. Like, the only way I know to absolutely guarantee that there is no way to cheat out on this is if you actually just remember who the sword has hit and who it hasn't hit. And you only process the hit once. Make sense? Okay. Now you may ask, why don't you just use sort of when does it enter the person and when does it leave, right? So only on entrance. But the reason for that is because you end up in situations where what if the monster and the sword were moving in the same direction, right? So suppose the sword and the monster end up in a situation like this, and the monster is moving that direction, the sword is moving that direction. Well, you could imagine a thing, even if you had really good collision detection, and you'd implemented everything perfectly, you could end up with these two things perfectly lining up, so they just overlap, right? And because of numerical imprecision, you oscillate as to whose side this is on as the monster and the sword move in that direction. And it causes multiple damage, you know, records to happen here, right? You could imagine this. You could imagine it with the power of imagination. Now, it's an open question whether this is a case that would ever happen enough for you to care, right? Furthermore, you could imagine a situation that's not so unusual, maybe. Let's talk about another one. Suppose here is Monstar, right? And here is Sword. This is a very fast Monstar, right? It's a speedy Monstar. The Sword is a slow sword, for whatever reason. The sword is traveling this direction. The Monstar, the speedy Monstar, is staying still. Okay? On frame 1, here's frame 0. On frame 1, the sword is here. It is a valid entrance. We know that it was not overlapping the Monstar before, and it is overlapping the Monstar now. So we correctly record -1 hearts. Right? But now, the Monstar accelerates in this direction. And the Monstar is faster than the sword. So on frame 2, right, the Monstar has actually gained some ground on the sword, such that by frame 3, the sword is no longer catching up. But now the Monstar stops. So on frame 4, the sword re-enters the Monstar. This would now record another -1 hearts and would be a bug, right? If we assume that the definition for our game is that one sword strike can only do damage one time, right? Now we could change the definition and say that if it does enter twice like that, that's more damage. Maybe that's a good definition, but it's worth noting that at that point we would be making that decision based solely on the fact that we didn't want to implement a more robust scheme that could handle either, right, of those two things. So I don't know. Like I said, it's very complicated. It's more complicated than you would think. A lot of games cheese out on stuff like this. A couple ways they cheese out is by like turning things invincible for a second after they get hit by something, thus eliminating this problem altogether. Another way is by eliminating the sword. Once it hits something, it's gone. There's a lot of different ways you can cheese out on something like this. And we could eventually decide that we want to do exactly that kind of cheesery, and then we would cheese it out. But at least at first, I would say, instead of picking the cheese route, let's try and pick a smarter route. And so the route that I would say that we should pick there is actually have some notion of whether or not a sword can hit something multiple times or not, right? So I think what we probably want to do is have essentially a sword. We want to have something called like a hit table, right? We want to have something where we can record every time something hits something in a mutually exclusive state like that. Let's just go ahead and record that somehow so that we can go ahead and prevent double strikes of this nature. Now, I don't think this is a particularly costly thing, even if we implement it stupidly. And the reason that I don't think that is because we have to ask the question, how many hits per second are really happening here, right? Assuming that this is a Zelda-like game, you're talking about having something, like 10 is actually a lot of projectiles on the screen. This isn't bullet hell. So, if this was in a bullet hell game, you can imagine that you would have some kind of a circumstance where you're thinking, oh, 100 isn't a very large number of bullets, or maybe even 1,000, right? But in our world, 10 is a pretty good number that you would think, like, that's a pretty hectic screen. The player is pretty frazzled if there's 10 things flying out there. Certainly if there are 100, stuff has gone totally bonkers. And the number of actual entities on the screen that can be hit and have damage done to them is going to be real small. Again, I think in that 10 range, right? So I think we're talking about circumstances where this table is, like 100 entries long or something. Something that we could scan exhaustively, if we wanted to, every time a collision occurred and not actually care at all. Because again, there's only 10 entities that could even get hit on the screen at any given time. So we're talking about 10 times 100 is 1,000 iterations total to process this. It seems like something that's really just not that big of a deal. So I feel like the hit table is kind of the right way to go, because we can also, maybe we can get some leverage out of this, right? There might be other things we can do with the hit table that we might want to do later that would be hard to do without it, because the hit table is pairwise, right? A hit table records the fact that something happened between an entity and another entity. And we may want to store information there, like timers or other things like that, that would be difficult for us to store in the entities themselves, which are not pairwise, right? An entity itself doesn't have information about all the other entities. So by having a hit table, it gives us a convenient way to store pairwise information, potentially, in a way that would prevent us from having to bloat entity structures with lots of little arrays or other garbage like this, or pointers to optional arrays, which would be more like what we do, right? We wouldn't have to bloat those things, and it allows us a really nice, convenient way to store that, and also in a way that is much more boundable, right? It's much more boundable for us to do this. We can set aside some space for this, we can set aside an iteration count for this, and know that at the worst case, we would not cause some kind of a memory overflow or use too much space or something. We would just, there'd be just a thing in the game where if there were thousands of things happening on the screen, hits at one time, one of them wouldn't get recorded or something, right? One of the hits would be able to happen twice or something. So at the very worst case, we would only regress back to what would happen if we didn't use the hit table. There's nothing particularly negative that happens in that case. And I don't think that case would ever happen, so we're good. And certainly we'll assert so we'll know if it does, and we can adjust accordingly. But I think we're pretty good there. So I think this is what we want to do. We want to have a hit table. We want to have the sword be an entity. And we'll go ahead and just put that in as I just described it. Looks like we've got about 30 minutes. That should be enough time to put something in along those lines. So let's go ahead and check out our move entity, right? We've got our move entity call. And what we want to do here is we probably, on move entity, we probably want to do something where we're going to, we've got our collision detection function, right? This is our collision detection function. And in some sense, for our sword, it's much too heavy weight, because the sword is not really moving. The sword just comes on the screen. I guess if we actually have the sword kind of travel out, maybe I take it back and we shouldn't have a sword string. We should have the sword actually travel out, just because it's a harder case. So maybe we'll do that. And so then when we do this iteration, when we go through here, every time we hit something, what we'd want to do is we already have it set up to process these collisions when they occur. We could go ahead and process those collisions now for real. So we could actually do something where we actually handle the collision, do something intelligent with it, So for example, the thing that we would do here is when that hit happens, we would go ahead and and we would just go ahead and make that decrement the hit count. Now there is kind of a slight issue that I didn't discuss, which is we need to know when things can get eliminated from the hit table, right? In the case of the sword, it's kind of it's a very easy thing. Once the sword strike stops, all the entries in the hit table that are about the sword can go away, right? So the sword strike only has to track that during that time. Now, whether there are more difficult metrics we have to worry about sort of further down the road, I don't know, but that's just an example of something we have to think about. All right, so let's go ahead and make a sword, right? So let's just add one in here, sword, like so. And so when we do we have our add monstar, right, call, and we can basically have an add sword call, and the add sword call is going to be pretty straightforward. An add sword call doesn't actually have to have a location because the sword is not really at a location at the beginning. And so that's kind of a good thing. This reinforces, remember I said when we were working on it before, I was like, I don't know whether we need to have the concept that entities aren't at locations. And I think this kind of answers that question for us. If we want to have things like swords that kind of come out to do a strike and then go back into sort of like hiding, the sort of stuff that we put into our world to handle the concept that things might not be somewhere actually isn't wasted. We are actually going to make legitimate use of that. And so that's a good thing. Again, it reinforces sort of a feature that we speculatively allowed for other reasons, specifically just so that the null entity could exist. And I sort of said, I don't know, do we want to do that just null entity? Well, now we know there's a real valid reason why we might want it. That kind of supports that as a general decision, to me, in my mind. All right. So we have our sword here. We know that the sword does, in fact, collide, although I guess in some sense, no, it doesn't collide. We do collision testing with the sword, but it doesn't stop things. People can walk through the sword if they want to, at least that's how I remember games like Zelda generally work. Sword does not have hit points, obviously. A sword does not have a location at all. Oops, add sword. Add sword. There we go. Having a little typing problems there. So we don't need to do this, and we don't need to do this. We are just adding a sword, and the actual position is nothing, right? So that would be how we would add a sword. We would then say when we add our player, our hero, right? Oops, add player. When we add a player, we know that the player should also always have a sword, I assume, for now. I mean, I guess obviously later on that's not exactly what happens. You kind of pick up swords or other stuff like that, so I'm not sure how we'll do that. Maybe that's another thing we should put on the list of stuff to try. So if we want to add a sword, we've got to add a sword here, and that's going to return an add low entity result for us. So this is our sword, right? So if we add our sword here, what we'd like to be able to do is store with this player what sword is theirs, right? So again, that comes in here. I'm going to get rid of this for now since we're not keeping particularly good track of this. So this comes in here now, and this says basically like what is my sword low index. And again, this is just kind of, we're building out this here, and my assumption is that after we add a sufficient amount of complexity, this will be huge, and it hopefully will have a lot of different things in it. And then that will put us in a perfect position to do like the pass that we need to do where we go and think about how we're going to store this stuff, right? Because not all entities have a sword, so why do they all have a sword low index, right? Or something like this. So anyway, so off I go. I'm going to say that this entity, the player's entity, it has a sword index, sword low index, and that is just the entity low results. I don't remember what the entity low result even has in it. Add low entity result. Add low entity. I don't even know what's in there. I guess just low and low index. Okay, so I can just grab the low index out. So now we actually know exactly what sword it is. So now when the player actually goes to use that sword, we can go and do that. So I guess what we would do here is say we also probably need some kind of a timer or a distance metric, I guess. Something along those lines. Because when the sword is active, we know that, like, you know, when you throw a sword or something in one of these games, typically what'll happen is the sword, it may, well, first of all, I think if it hits something like a tree or something like that, it's obviously going to stop traveling. So if it hits a wall, like, it'll stop traveling. But it may also, we may also have a situation where, like, if the entity, if the sword entity goes for too long, like there should be a timeout on it. So I don't know, or a distance stop. Like you can only throw the sword so far, right, before it stops. That seems pretty typical. So I assume we'd probably want something like that as well. So we'd probably want something on here like a timer, right? Where we're going to set that to something that's going to tick down, and when it ticks down, the sword goes away, right? And this might be a total distance traveled. Seems a little smarter, so maybe we'll say distance remaining or something like that, right? So we'll look at that and we'll see how that goes. So we've got distance remaining, and now we've got our sword. We've created the sword, and so now what we need to do also is, I guess, draw the sword. I said that we would just kind of throw in there one of these like cheesy rock bitmaps. I think we said it was rock 03, something like that. So we'll use kind of a cheesy way of representing the sword, since I don't have a sword bitmap in the art pack yet. So that'd be here. Sword. And then when we're actually down here drawing stuff, we would just say, what do we want swords to look like, right? And swords are just going to be like walls where there's really nothing interesting in them at all. They are just sword. Now, if we're actually using that rock 03, I guess is what it was. If we're using rock 03, I need to kind of see where we should center it around. I assume we'll just use the middle. So however big it is. Well, I guess I'll just kind of feel out what the middle is in GIMP. So probably like right about there. So that's like 2910, right? So 2910 is the centering point for that guy, and that is the bitmap. Now, in general, I guess the sword should kind of be a little bit off the ground, which means it probably has a shadow as well, right? It's got something like this. So I guess the swords technically have Z height, and we'll probably give it a little Z height when it gets thrown. That's what I would say. All right, but we'll deal with that a little bit later on. Okay, so now we've got swords, and so something that we have to check now, which we weren't checking before, is when something is a high entity or a low entity or whatever. We weren't previously checking to see whether it actually existed somewhere in the world. I guess, well, it wouldn't be in the high entity set. So that's what would prevent it from happening. It would drop out of the high entity set. Or go into the high entity set when it existed or didn't exist in the world, because the criteria for moving something from low to high is that it's in the camera region. Yeah, so I think that's good. What I would like to do now is, let me clean up any errors that we may have, compile errors that we may have done here. So add sword obviously has to be above add player so the compiler can find it. Rocket Science C compilers can't find functions if they don't happen in order. All right, so let's go ahead and actually change the action up, I think is what it was. Let's change that to be whatever the spacebar was. I don't remember what we called that in our platform layer. We had a couple different buttons. I think it was actually the start button that was that for jumping. So I'll just bind that to start button for now. I don't think we're actually ever going to have jumping in the game. But it was kind of funny to watch him jump around in there, so I'm going to leave it in for now. So I think, yeah, there we go. Okay. So start button is also the jump button at the moment. It makes no sense, but that's just the way it is. So now we just need to bind these other keys, the arrow keys, to launch a sword in a particular direction. All right. So let's start by saying, okay, we know that if we got a situation where the controller's action up button ended down. Oh, you know what I could do too here? Well, I don't really want to. Never mind, that's not going to be useful. I was going to say something, but then I changed my mind. So we basically have a direction for our sword to go in. And we're going to assume that the sword doesn't go in any direction. And then if they actually push in one of the action directions, we'll just launch the sword, right? So we'll say that there's the up, down, and the left, right sorting, right? Like that. And when that happens, we will set the D sword to be the direction we want the sword to go. Again, nothing particularly interesting here, just really, really basic stuff. Just something so that we can kind of have a sword going and see what happens as a result. So there's left, right? And there's right. Like so. So that allows us to launch a sword in any given direction, but now we need to actually make sure that we take our sword and launch it. So after we move ourselves, what we want to do is say if that D sword is, so I guess the dot X is not equal to 0, right? Or D sword Y is not equal to 0. So if we actually decided that the sword should have some launching here by setting it to one of these things, if that was the case, then we need to initiate that sword sequence. So now, first we should check to see if we even have a sword, right? Because technically, I guess we don't have to have one, right? The person might not be having one. So we should check the sword low index. We would see whether or not we actually got one there. So we could look at get high. We had a call that was like get high entity or something like this. It was like force entity to high, right? Like so on. So what we could basically do is just call this, right? And so we want to force the entity to high. That's whatever the which entity actually? Where is our controlling entity? That's what it was. So controlling entity is what? An entity structure. So our controlling entity, we want to take that and say that it's sword low index. We want to force that to be a high entity. So this is our sword. We've got our sword now, right? And if our sword, we know that it could come back like nothing. It could come back nothing at all, right? So assuming that we got a sword back, because if this sword low index was 0, this will just return a null pointer, and because there's no sword to have. So this will force the sword entity into the high set, right? What we want to do now is say, okay, now let's actually move the that sword to where we want it to be. Now what's interesting about that is I'm kind of interested to know force entity into high probably already does the mapping, right? So what we'd really want to do is before we did that, this is kind of inefficient, and I don't love it. Kind of what we would want to do is we'd want to get the low entity first, set its position to where it should be, and then force it into high, right? So it's kind of annoying and inefficient. I don't know, maybe I want to change the way that API works a little bit, right? I just don't love it. Because I would like to be able to say to do that in all one go, but I can't. So no, I could do. Maybe I like it this way. Maybe I like force entity into high to actually take an optional place. So when you force it into the high set, maybe that takes a position, right? So it's like I want to force this into the high set, and I want to force it into the high set here, right? So basically what that would do is it would change the entity location, like so, right? So this would change the entity location, and then it would force the entity to be high frequency if it wasn't already. So we'll change the entity location. We'll say that the entity location is here. And then we'll start simulating it. Well, you know what? Maybe this isn't even really that. Maybe I'm even being more ridiculous here than I thought. Because what I could do too is say, well, maybe we don't ever even get its high. Maybe we don't we don't treat it as a high entity at all. Maybe we just treat it as a low entity the whole time, right? That would essentially be saying, all right, let's see whether there is a sword, right? So we'll basically say low entity sword equals get low entity, and we just get it. There we go. Assuming that there is one, we then change its location to where we want it to be, and then we don't force it into high. We let the camera stuff code just force it into high as it would. I don't know. So maybe I was overthinking things, and I should just let the systems do their job. I do think that change entity location, we probably have to think that through a little bit more, because I feel like at the moment, right, change entity location should map things into high probably if they're within the camera bounds, if that makes sense. So I feel like there should be a to-do here that's like to-do, if this moves an entity into the camera bounds, should it automatically go into the high set immediately? And that's really, at the end of the frame, on the next frame, it would go into the high set when the camera did its check. But do we want it to go in immediately so that for the rest of the frame after it's created, for the rest of that frame, it actually goes through? And I don't know. So I'm just putting a to-do in there. All right, so I get that low entity out. I go ahead and see if there actually was one. And if there was, I'm going to go ahead and set it to be where the player themselves actually is. So this controlling entity here, whatever that controlling entity is, that entity's position is where I want this entity to be for now. We'll set ourselves up for success here to say where we want that to be so that we can modify it later. Set the Z or whatever we want to do there. So we'll have that, and maybe we even do set the Z here or something, but we'll play with that a little bit later. And so we're going to change the entity location. We're going to change that that sword entity, its location, like so. Right? And I think that's really all we needed to do. What is the 0? That's where it was. So I think that's correct. The only thing that I would say is if the sword is already in play, you shouldn't probably be able to recall it. So what we probably should do is verify that the sword is not actually already inserted in the world. And unfortunately, right now, I don't think we really have a way of representing that. We don't have that notion in our actual entity structures, right? Correct me if I'm wrong. But there really isn't anything that says for a world position whether or not that world position is valid, right? So what we could do is introduce some notion of that, right? We could introduce some notion that a certain set of this chunk indices indicates an invalid offset, right? And that would probably be something along the lines of one of these very large values like int32 max, right? And so what we could do is say that there is such a thing as that and introduce sort of a rep there, right? So the way that that would work is when we add a low entity, if the low entity didn't actually have a position that was asked, that was supposed to be the position where the entity should be, right? Oops. Then what we would do is right there, we'd set its sort of settings for its position. We'd set that equal to the null position, right? Like basically like a position that says it's not in the world. So the null position would just be some function that returns a world position like this. There's our null position, where you can at any time get one back. It's basically just one of these that's set to something that specifically lets us know that it is not valid, right? So it's just this, let's say. Chunk x is that, right? And we return it. Because we know that you can't put things there. We already are using tile chunk uninitialized as a marker in our hash table, so you're not allowed to use int32 max as a valid location for something. So what we could do is just say that is what the null position is, right? And we could clear everything else to 0. I don't know if we should or not, or if we should let it be garbage. But for now, I guess we can clear it to 0, because why not? So this will set that to be what we just said. However, what we would like to also do is say we want something where we can say is null, and we give it a world position. And I guess we could just, since that's an inline, we could just say result equals p chunk x not equal to tile chunk uninitialized, right? We could also say is valid instead. Is valid might be a little bit better, and then that would be right this way. That's the way I actually wrote it, was for is valid. Okay, so if we do that, then what we should be able to do here is we should be able to go ahead and also add an assertion that whenever you do a change entity location, what we could do here is these could we wouldn't have to make these pointers anymore if we didn't want to. right? We could make it so that they actually were just using the invalid or valid. I don't know if we want to do that or not. We'll see. But what we should do is we should say that we can assert either that the old p is null or that it's valid, right? But you should never be able to pass us an invalid position as part of the thing where we're changing the locations, right? Because this already has passing 0 as that. So we'll just do that and make sure that that actually works. What was I doing here? World position. That's true. It does not have an overloaded. You are very right. And these are just copy-pasteness. Obviously, those should not have start in front of them. And then change into the location. Let's see. Cannot invert argument 1 from game state to memory arena. What are you talking about? Change entity location. Let's see what's going on there. Change entity location. World. Change entity location. It should take an arena. What did I cut and paste this from such that it didn't take the arena? That's particularly odd. Yeah, I don't know why. All right, but either way, we do have our arena here, our world arena. So we have our oh, I guess it doesn't take the game state, it just takes the world arena and the world, like so. That's what I did. So let's take a look here. What have we got? Changing location first 1 from arena to memory arena address, that should be fine. Cannot 5 world position star, that should be fine. So what we need to do now is check to see if the sword is there and it doesn't have a valid position, right? Then we know that we can move it to some place where it actually is going to be valid, and that should move it into the high entity set. So that would make the sword appear. Now that is all it will do. That's the entirety of what it will do. So I don't actually know. What we need to do here is set a breakpoint to actually see if any of what we just did was working at all. Let's take a look. So let's go to the part where we launch it, and I'll launch it to, let's see here. Okay. So let's see what happens. Here's my guy. I go to launch the sword. What's going on? So sword P is what? It's in the 000 chunk. It's at a location. I assume that's where the player is. I don't actually know, but that would presumably be where. We can go ahead and do that. Looks like that works totally as expected, so that's good. And then we would expect on the next pass through, we would expect to then get into a position where we were going to draw it. So we would expect to hit this, not this time through the loop, but next time through. And of course we don't. So for some reason, that is not getting moved into the high entity set for reasons that are not immediately clear to me. Because you would expect afterwards for that to be moved to the high entity set, and then it would get looped over here in a way that would eventually tell us, okay, it's time to draw this. Now what's interesting about that, let's think about this first. I think that, I feel like that should have worked. So something in our change entity position there, or change entity location, something in our change entity location did not properly put it somewhere where the set camera call would find it. The set camera call would have happened immediately thereafter, which should have brought it into, I guess now that I think about it, right there, should have brought it into the active set. So for some reason, it did not get added. Now what I'd like to do here is have a way to sort of check that procedure. And so what I'd like to do is see which entity that actually was. And what I'm going to do is I'm going to go in here and put in a call so I can just stop on that one when we do the set camera. So in set camera, when we do this, the make entity high frequency, what I'd like to do here is just basically stop whenever we find that entity and make sure that something weird is not happening there, right? So let's go ahead and do that here. Let's see, we got the low entity index. Let's do if low entity index equals, 3, let's say. Or I guess we'll just say if low int test entity index equals 0, if equals test entity index, and we'll break here. So this will be like int foo equals 5. Okay. Signed unsigned mismatch. I'm so sorry. I did not mean to do a signed unsigned mismatch. So let's go ahead and check now to see what happened there. We'll go ahead and do this. And again, we haven't done much with our spatial partition yet, so we may just have some bugs in there. This is the first time that we're actually really doing anything substantial with any of our stuff. So let's go ahead and I'll set that breakpoint as well, and that one. So let's go ahead, and we've got one set when we actually start. There we go. Oh wait, I can't actually quite do that yet, I suppose. So when I actually do my shot, there we go. Let's take a look at what that entity index actually is. So the sword is index 92005. That is a lot of entities that we've created so far. So we've got 92005 as our entity. Uh-oh. We're out of time. I'm just going to go ahead and just finish looking at this, just because I want to see if it's actually finding it here, and then we can finish the debugging tomorrow. So I'll go here, I'll step to it, and I'll take a look and see. We're going to check against test entity index, so I'm going to go ahead and set test entity index to be equal to 9225. There we go. So now we'll break in here when that guy actually gets found, right? So let's see. Okay, so basically he's just not going into the spatial partition in the right place or something, right? Because he never actually gets found in this call series, right? That never actually happened. So if you actually go and look here, I'll just verify that it actually did it right. Test entity index. Let's take a look. Test entity index equals, oh, that's not going to work. I did that wrong. That was supposed to be a static. My bad. Local persist. What did we actually call it in this code base? I forget. I think it's local persist, but I could be wrong about that. Local persist. That's what I actually meant to do. My bad. Let's try that one more time. Now the sword should be the same thing here actually, because as far as I know, the you know what? I should probably move this up as well. Should probably just do this. There you go. So what I want to do here is I want to go ahead and do that one more time. Come down here. The sword it presumably is at the same entity index because I don't know why it wouldn't be. So let's go ahead and verify that that's true. 92005. It is exactly as we would suspect. So let's go back up and try that one more time. I actually meant to, so to have test entity index is now global, so I can just set it to whatever I want and run and see if that ever actually hits, and it doesn't hit. So that's concerning. That basically means that something I did there was, unless I made a typo. So assuming that I did not make a typo. What that means is our spatial partition is not quite debugged yet, because once we do this change entity location to move the sword P to its new location, it should be at the same location as the entity is, and at that point, it should be triggered as something that's essentially going to be moved in with the camera state. So if we take a look at that call, again, sorry to belabor it here, I'm just kind of curious. I would like to know. If we take a look at what happens in that call, I'd like to see what spatial partition it's actually added to, right? So let's go ahead and get that chunk here and see. So we got back chunk 000. There's already 10 entities in it, which looks reasonable, right? And so there's those low entities. There they are, right? And so what I'd like to do, there's the player and the Monstar, presumably, and the familiar. What I'd like to do is see now, when we add this, right? Let's add that in. What actually happened there? Block entity count. What did I miss? That did not go up. Something weird happened there. Let's try that one more time. I need to step through this more carefully, clearly. All right. So we get a chunk. We get a block. The block is the first block, which is exactly what we would expect. So if I look at the block, or block, as perhaps I type in, I have the entity count. They store 16 per, so 10 is fine. And so what we should be doing here is we should be incrementing it by 1. Now, it could be that it was just the compiler being ridiculous. Oops, that's not what I meant to do. So I want to do one more check, which is just, let's take this actual value here this actual pointer value so we can take a look at it even after the scope exits, because Visual Studio is awful at being able to show you variables when they exit scope. It's really, really bad. So what I want to do is just make sure that we're still looking at it properly. So world entity block, at that pointer, there it is, and there's those low entity index. So 10, this one should get filled next, right? These should be irrelevant entities that aren't actually doing anything right now, because there should be only 10 in there. So we go ahead and do that. This should increment it by 1 and stick it in there, which it did. And so this is, this block that has 11 things in it. Now the question is, why does that block not get iterated over to move things into the high set? So let's take a look when we go into set camera. Let's just find out, why it does that. So offset and check frequency by area we don't really care about. That's the thing that's removing things from the high set. We want to know why something's not being added to the high set. So let's take a look at that min chunk P. It's -2, -1, 0. Let's take a look at the max chunk P. The max chunk P. So that clearly would include the chunk that we're talking about. So let's go ahead in here and take a look at our code. So we're going to grab the first chunk here. There's nothing in it, so that's fine. Again, we're looking to see this block come up. So what I could do too is I could just make it right here where we actually see which blocks are. But let's go ahead and look at the chunks first. So let's look at the chunks first. So here we go. There's our chunk. The chunk was 0, 0, 0, if I remember correctly. So we should be able to find chunk 0, 0, 0 here at some point, right? What is our chunk Y, chunk X? There's 1. There's chunk 0. All right, so our first block is the actual block that we thought it should be, right? And so entity 10 should actually be the entity that we're trying to do, the sword, right? So let's see what happens. We go into the block. I don't know why it highlighted that line. That's a little odd. Let's make sure that nothing weird just happened there. Block. And then let's step through this. So we go through, we're looking at the first entity. It's 40. That's exactly what it should be. So that's not necessary. We come through here. We're going to go through, let me just go ahead and put that in there. Low entity index, right? It's 41. And so we can go through several of these until we get up to the one that we actually care about. And all of these are already in the high set, which is exactly what we would expect. But the next one is the one we actually care about. And so here we are. This is actually 92005, which is the one we actually care about. So let's go ahead and see what happens. We get its camera space P, right? Its camera space P is apparently complete garbage. Why is this camera space P complete garbage? That's no good. That's no good at all. So I guess the lesson here is that change entity location does not actually set the location of the entity. It just updates the thing. And I guess we kind of knew that. If I maybe had been programming this code base a little more regularly, we just kind of know that. So the question is, should I do something to just ensure that? I mean, it looks like we're always doing that set anyway. So I guess what I'd say is, can we just get rid of this and make it so that that always properly updates it, right? So that was it. We really didn't have much of a bug there. It's actually just in our sword code. The spatial partition was working just fine. So really what we want to do is here on change entity location, what we would want to do here is on change entity location, we just want to update it. So basically at the end of this function, after everything's done, we'd say if there was a new position assigned to the guy, then we go ahead and say assign that new position to where they actually are, right? Oh, so that's why we didn't do it. We don't even have the low entity's address. All right, that actually makes some sense. So I guess what we want to do is we want to make that a little bit more, we want to make that be something where you actually pass a little bit more in there, right? We want to make that so that so that this is more like a change entity location raw, something like that, right? And then we've got something more like this, right? And that's enough code now that this is probably not going to be something that's called inline at all. All right, so this is going to be where we pass, you know, the low entity index and the low entity pointer, right? So that they can actually be assigned properly. And so in that case, it just goes ahead and punts directly to the other function. So it does the set like so, and then it will also go ahead and handle the assignment so that we won't have that kind of bug, because that's not a bug we want to be having a lot, right? It's annoying and it's hard to track down. It takes a little while. So I'm going to go ahead and make that so you call through this from now on. And what that's going to do is going to say if there was a new p, then it goes and it says that the low entities p equals the new p, like so. But if there wasn't, then it'll say that the new entity p equals the null position, right? Like that. And so that should basically do it. I think that's about it. This would now just work, I think. Could we just call that straight away? If old p are in the same chunk, old p and new p, but if there's no old p, what happens? If old p, it does this, and I guess we want to do something where it does if new p, do this, right? So we won't do that oops, I'm behind my head, I can't see what's going on. Yeah, so what we'd want to do is allow this function to take it so that they could both be null. So at that point, you wouldn't even have to do this anymore. You just do that, and then this happens to be null, it just works, right? And that looks pretty good, I would say. Okay, so this node doesn't take that, obviously. So these guys all now just take that low entity as well. And then I think it's all good. I think, if we're lucky, that fixes our problem. This guy does an over assignment here, it looks like, or no, it doesn't. So that's fine too. Change entity location. That will take that actual sort entity. And then I think that's done. All right, so hopefully we fixed our bug. I don't know if we did or not, but we'll have to take a look, I guess, and see if we did. There we go. So yes, there we go. We were able to drop our sword now, so we're all good. All right, so basically tomorrow we will continue on that route. We'll implement the table that I talked about at the beginning here. And then I think that should be about it for our sword. And then we can sort of focus on what happens with hit points and that sort of stuff. So that seems pretty reasonable. Sorry, I had to go about 5 minutes over there. I think we started about 5 minutes late. So it wasn't too much longer. That's not too bad. And it's good, like I said, you never want to leave bugs in your code base. You always want to find them as soon as you possibly can, especially in that circumstance, right? That was a good one to find too, because we moved the code into a better place where that bug can't happen really anymore in that way. And so that's like what you want to do. You want to always be moving towards something where bugs that happen once don't happen again. Because it doesn't cost a lot to hunt down any individual bug, but if you have the kind of bug that perpetuates itself, that's where you start getting into trouble. All right, so let's go ahead and start the Q&A. If you could, please prefix your question with Q: so I can see it. And please try to keep it to stuff that we did on today's stream or that we have done on a previous stream. If you want to ask off-topic questions or ask about things that we might do in the future or how we might do something, those are totally fine questions to ask, but please ask them during the pre-stream. So come about 15 minutes before the stream starts. That's when we do off-topic stuff. All right. QA. It is QA time. What do you mean that Visual Studio is horrible at showing variables? So I can actually tell you exactly what I meant. I can literally just step through that same thing again that I was showing before. And it's the kind of the classic case of how bad Visual Studio is at showing you variables. And it might be my imagination. Sometimes, you know, my memory, I'm old, right? My memory is not so good. But I seem to recall that this didn't used to actually be a problem. I feel like they actually broke this. But who knows? So here we go. I'm stepping through here, right? And I'm in a situation where I've got this variable, it's called block, right? And here it is, it's defined right there. And I want to see what happens to block after this line is executed, right? So this is literally what I just did, right? You remember seeing me do this. So I have this block, it has this array, it's got an entity count, and I want to see what it does to this when I step over this line. So I hit F10 to step over the line, and watch what happens, right? You have no idea what happened now. This is what it shows you. It shows you stale information. This is not even what is still at this pointer, right? It's freaking ridiculous. And now if you hit the refresh key, it deletes the whole thing, right? And I don't know if there's a way, I don't know, like you might be able to just refresh one of them. Like, so here's block, and here's this, and I step, and now like I refresh just that one. No, you can't even do that. So it's just awful. Like, it knows the pointer's the same, it didn't change, just show me what's at that location, right? It's horrid. And it didn't used to have this problem. It used to be in like Visual Studio 6 and stuff, or at least in 5, it must be 5 or 6. It would just still show you this after the fact. It'd just be like, well, this is what at the memory now if you want to see it. And like, yeah, I do want to see it. And so you have to go through all these gyrations. It's just, it's really bad. Visual Studio has gotten worse with every revision. It's awful. And unfortunately, you have no choice but to upgrade because you need the new code gen. Like, you need to be able to upgrade to the newer compilers to output to like x64 first, and then to AVX, AVX2. You need to upgrade to the newer compilers. And when you upgrade to newer compilers, you have to upgrade to the newer debuggers because the older debuggers can't support those newer instruction sets and blah, blah, blah. And then your debugger just gets worse with every revision. So yeah, this debugger is like 10 times worse than the debugger that came with MSVC5. It's way, way worse. Unfortunately, that's par for the course with Visual Studio. You like brace yourself every time they come up with an upgrade. You're like, what are all the things that they broke in the upgrade, right? When doing exploratory experimental programming, I find it difficult to decide between seeing things through or switching to a different approach. There have been many times where I start off on a path and things are going great, but eventually I stall due to some unforeseen problem. Often I spend a crazy amount of time thinking about how to get around the problem, even in simple ways. Analysis paralysis, if you will. Any suggestions? Literally just keep on writing code no matter how dumb it is? ? I'm out of cough drops, which is never a good thing. Side note. So it's a kind of a case-by-case basis is what I would say. Obviously, and this was kind of a thing, this actually came up on the forums a little bit. Someone had pointed to a person who had a blog post who was kind of saying that, I often say compression-oriented programming is a good way to go, right? You explore, you compress, explore, compress, right? And this person wrote a blog entry, excuse me, where they were talking about how like, well, that doesn't really work because you might compress the code wrong, right? Which is a hilarious objection to have because it's kind of like saying, you ask someone, if you go ask, Usain Bolt or whatever, how are you running? And he's like, oh, well, you start off and you like move one leg in front of the other one and you push on that one while you lift up the other leg and put it in front of the other one and you just repeat that process, right? And then someone goes out on a track and they like follow those instructions and they're like, why am I not running as fast as Usain Bolt? I didn't break this. And you're like, yeah, because, you suck at running. Like, sorry, right? And that was the case of the person in the blog post. And so the answer there is like, we're all trying to be Usain Bolt, right? We're all trying to go in that direction. We're trying to get our sprint up to that speed. We're trying to do it. There's the argument about what is the right ways to run, meaning the mechanics of it. But then there's also just the practice involved, right? And no amount of knowing how Usain Bolt runs is actually going to let you run at his speed. So what we're all trying to do, and I try every day when I'm programming, I'm constantly trying to improve as well, right? I'm trying to get to Bolt land, right? Is there's the analysis of the mechanics, and then there's just the practice. And unfortunately, at some point, it is the case that the practice is what really counts the most. And so what I was going to say about your question was there's a split there. Some of what you may be running into is stuff that you can think about in terms of abstract mechanics. Like, am I putting one foot in front of the other right? Like, am I pushing off right? Am I doing these other things right? That we can talk about abstractly. But the other half of it, from the analogy, right, is just the practice, is just the running every day and tuning all of your instincts and your locomotion and everything so that you've got it down where you can really go super fast, right? And that's the part that is not necessarily something you can talk about abstractly, right? Because there's so many different techniques that you might learn and intuitions that you might build up over time, having architected lots and lots of pieces of code, seen how they've gone, understood what their limitations are, that sort of stuff. That bank of knowledge is not really replicable with someone just saying, here's how to do this process, right? And that is also something that I think is a problem with a lot of computer science or computer programming related stuff, is they talk about methodologies as if those methodologies are themselves executable directly. But there is no such thing as that in my experience. I've never seen a thing where you can just say, here is how you design code to someone, and then they go design good code. That doesn't happen. You can say, here are the different procedures and how they work roughly, but there's still a tremendous amount of inherent knowledge that nobody has figured out how to communicate that you just have to practice and get better at, right? So to answer your question specifically, after giving that kind of very long framing about it, right, is there's two things you can do to get better if you're having trouble with code architecture. One is to think about whether there are systemic things you are doing that are problematic, right? And that is the first part that I talked about. And that's stuff like, are you actually writing enough usage codes first? Are you actually taking the time to think about how something's supposed to work? Are you actually spending the time to stop and write little use cases for all the things that you were doing and verify that you really were writing them the right way? Blah, 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 right? Are you actually doing the mechanical steps of good, like compression-oriented programming, data-oriented programming, whatever it is that you think is the methodology that you want to use? Are you actually doing that? Or heaven help you if you're an object-oriented programmer, still same thing applies, right? Are you actually doing the steps that object-oriented programming professionals would have told you to do, right? And that part you can do cerebrally. Like, that's the part you can sit down and say, am I actually following the advice of the people who are experts in this field? Am I actually doing the same things they're doing, right? So I don't know, like I said, I can't see how you're coding, but you know, the first question to be asked is like, can you identify any of those things that you're not doing, right? And then the second part of it is to go, okay, if I don't think that that's my problem, so I'm looking at the kinds of problems that I'm having and I don't think that's it. I did try the use cases. I did have a good idea of what I wanted this code to do. I did have examples of it that I wrote. And then when I went to do the architecture, I still messed it up, right? That is a case where I think you're probably just in that unfortunate place where you just haven't had enough practice yet, right? And there's really nothing you can do to short circuit that process other than write lots of code, right? The more code you write, the more practice you will get, and the less mistakes like that you will make, because you will have seen the consequences of different types of compression you can do, of different types of structure of the code. And then when you are making your decisions, they'll all be that much better every time, right? And so one thing you could do to accelerate that process is you could start trying to tackle smaller problems. Take something that caused you a problem, like you're talking about you're having a problem, so you've isolated something that was causing you a problem. Can you pull that problem out? Can you iterate it on a few times? Can you take your solutions that you then come up with? How do you feel about them? Can you post them like on the Handmade Hero forums? And we'll look at them and see what other experienced programmers have to say about those solutions. Are they good? Did you make obvious mistakes? What were those mistakes, right? And by maybe cranking up that iteration time, you can get more practice at the parts you're bad at, right? Instead of having to go through whole projects with only them coming up occasionally, and then you're really not getting that much practice at any given one, and the cost is high for those mistakes because you've got this whole thing around it, right? And so I don't know. But that's really all I can say about that. Is that gives the full framework of how I think about it anyway. If you want to run like Usain Bolt, you gotta be willing to do both things. You gotta be able to know that you're doing the right stuff mechanically, but also that you're just practicing every day and getting all of those subtle things that no one really quite yet is able to communicate how to do them in a way that doesn't require you to learn them yourself and have them ingrained. You gotta do both. And I don't know that there's really any substitute for those things. Will you handle the case where a sword and a Monstar would hit each other, but are moving toward each other so fast that they pass through each other without colliding in a single frame? Yeah, so our move entity code already does that. Right? Our move entity code, which we'll just probably call for the sword as well, our move entity code already handles that case. Right? Because remember, we did Minkowski and we did raycasting, so we don't, tunneling can't happen in our system right now. Do you think cheesing, like making enemies invincible for 10 frames after being hit, is a game design sin or just something you'd rather avoid? I think it's if we were going to use the word sin, I think it's just a handmade hero sin. Like basically the reason that I'm doing this stream, right, is because I want to sort of demonstrate how I do game programming. And so what I want to do is try to do a good job on all of the things that we do. So I'm trying to make sure that we set everything up to do a good job. When, you know, in a couple weeks or so, when we switch over to doing the real engine code, I want to show how to do a very good job on each of those pieces. And then, you know, at the end of the day, the goal for the series is to have each thing that I showed how to do be done at a high level of quality so that people can learn from it, right? What I don't want to do is show how to avoid doing good work by designing the game to not require it, right? But that does not mean that's what you should do when you are making your game. And the reason for that is because certain game design decisions could save you a lot of time coding. If a particular algorithm necessary to handle a particular aspect of the game design is very hard, and changing the game design to something else would not actually cause a problem, but would eliminate this hard thing that you don't have time to do, that may get the product done sooner. It may keep the momentum of the project up. It may do a lot of positive things for you. And so I definitely don't want to say that nobody should cheese things. All I want to say is you should know how not to. And then you can make an informed decision on every individual case, whether or not cheesing was good or bad there, and then you either cheese it or you don't, based on your instinct for whether the total impact on the project will be better or worse whether you cheesed or not cheesed. Because again, there's only so much time in the day. Everyone, you know, time's the only non-renewable resource, right? As they say. So if you go into something and you think, oh, I'm just going to do as hardcore engineering on every last thing as I possibly can, well, that's probably, honestly, as much as I admire that mentality and as much as I think that's an interesting mentality to have on some projects sometimes, if that's what you wanted to do, right? And it's sort of what we're trying to do here and that we'll keep trying to aspire to, right? As much as that's interesting here, that may not be a very good attitude to have when you're actually developing the game. When you're actually developing the game, you might want to have more flexibility. Know what the good engineering would be. Learn enough so that you know, so that you don't have to cheese, but then at each individual point, decide to cheese or not based on what would be the best for the project in the whole, right? That's important. Because if a project that would have taken 2 years takes 10 years because you refuse to do any cheesing or something, right? That was 4 more games maybe you didn't make. And so, yeah, this one game may have no cheese in it whatsoever, but was that a good decision for the whole time, right? And so you always have to be making those trade-offs because everything is a trade-off, and you can't have one dogmatic thing that you just always go by, because I think you'll end up making bad decisions if you do. Simulatory, why not just use the auto window? Well, because I was trying to look at something specific and I like to have my watch window set up so that I see the things that I see. Like I tend to set up things so that it's listing exactly what I want and things don't move around and don't change. You can use the autos window for people who want to use it. It's in the debug Windows auto, right? It's right there. Like you can see it here. And this gives you the things that are kind of like what it thinks you want to see. Unfortunately, you will notice that the problem that I just said was that have the watch window is even worse with the autos window. When you step over that block, everything goes away. So even though you could use the autos window to save you some time typing things into the watch window if you thought that was a problem, I personally don't like the autos window, so I don't use it, but it's worth noting the autos window does not solve the problem that I just showed. Is Visual C++ still better than open source alternatives? The debugger is, although give them a few more revisions and maybe it won't be. Like the debugger gets worse with every time. So at some point it may be that Visual Studio Debugger is so bad that Q2 Creator is as good, right? Or something. That could totally happen. Because every release, Microsoft ships a worse and worse debugger. So basically, like, at some point it may be that actually the open source ones are actually better. That could happen. But at the moment, no. The Visual Studio Debugger is still better than any open source alternatives I've seen. The compiler, on the other hand, is much worse. So the open source alternatives for compilers like Clang is much better than Visual Studio's compiler on every front, pretty much. There may be a few optimization things that MSVC does better, I'm not sure. But by and large, Clang does everything better. So if you're talking about the compiler, Clang is far superior. If you're talking about the debugger, Visual Studio, unfortunately, is still pretty much the best you're going to get. It's a sad state of affairs when Visual Studio is the best debugger you can get, but that's where we're at. It's a sad world. I'm just living in it. What would you think about adapting the art style to be easier to implement either at all or this early on? The trite example being for the sword collision you mentioned, what if you were to say something like, the sword is going to teleport along the path instantly in one frame, and some red line a bit like anime that would be persistent through a couple of frames, basically potentially fundamentally changing the art style with the purpose of getting things to run better. Are there any examples of something like this occurring that you might have heard of? So again, yeah, I don't have really much to say about that question that I didn't already say. You probably typed it in before I said all the stuff that I had said. So yeah, same thing applies there. Yes, you can always get out of a programming jam by changing art or game design. I don't want to do any of that on this stream because the goal here is to show programming, so we're going to take everything head on and stick with it until it works. We are not going to change the game design to benefit the programming. We're going to do the opposite pretty much exclusively. But that doesn't mean that isn't a valid option for you on your projects. You have to make that call every time based on what you think would be best for the project. Let's see. So it looks like we've only got maybe 2 more questions. So I'll answer these 2. Well, also 3. Are you working on the RAD debugger? No, I am not. But yes, I would start using it on Handmade Hero when it's ready. If RAD ships a debugger, even like a primitive one that's decent, I would totally switch to it on the stream. But I haven't gotten one of those yet. You always talk about the ways of programming when you started or when programming was at its prime. How can an 18-year-old know what it's like or get the knowledge you have about programming? Are there any books or languages or something I can do to learn the old ways of programming? So basically, Handmade Hero is mostly trying to be that bridge to some extent. That's why I started the project, and it's what we try to focus on. We're sort of trying to show the old school way of programming, but in a new context. So, we know now we can allocate 4 gigabytes of memory, and it's not a big deal, right? So we accept those things and we try to do powerful things with them, but we still write everything from scratch. We still write everything, at a low level, and we build up from the low level to a high level as we go on our own and try to practice that same sort of stuff that people did in the old days. Is it as hardcore as the people who did it in the old days? Absolutely not. They were writing things in assembly language from scratch, and it was a much harder world. They barely had debuggers. Half the time, they didn't have debuggers at all. We have it very easy compared to them. But I am trying to kind of create that bridge to show what are the good things from the old school programming, how can we bring them forward, and how can we kind of encourage other people to keep doing them. Are there good books on the topic? I don't really know. If you just want a taste of that sort of thing and just want to get a feel for it, as opposed to like a good thing to use to maybe for learning per se, I feel like the Bruce Artwick, I don't know how to spell his name. I feel like there's a couple books that were kind of classic in that way that you might be able to take a look at. This would be one example, right? Microcomputer displays, graphics and animation. This is by the guy who wrote Flight Simulator, the original Flight Simulator. I can't remember if there's other books along these lines. Maybe one of Mike Abrash's books, so like the Zen of Graphics Programming or something like that. Take a look at those. Those are available. Those might be some that would get you to sort of have a sense of what used to go on back then. They'll go through the thing of like getting a texture mapper down from 40 cycles per pixel to 3 cycles per pixel or whatever, those sorts of things. And like how they even implemented Flight Simulator at all on an Apple II, which was kind of crazy at those times and that sort of stuff. That might give you a sense for like the kinds of stuff they went through. As to how to learn to code like them, I don't know, because I don't even know how to code like them. Like I wasn't really in that. I wasn't alive in any meaningful sense in the 70s. I was born in 76. So by the time I was 4 years old, the 70s were over, right? So I never really experienced any of that. I didn't learn to code till like 83, I think. And so, I really just don't have that same kind of background. Let's see. All right, so I'll answer 2 more here. Why did you pick C++ of all things? So interesting. Like, I don't know why people think C++ is such an odd choice when almost every game is programmed in C++, right? People kind of look at it in like, oh my God, why would you be programming a game in C++? As if somehow not all games are programmed in C++, but almost all games are. Like the vast majority of games in existence are programmed in either C++ or something lower than C++, like C or assembly, right? It is only very, very recently that games started being written really in anything other than C++. I mean, if you went back and started talking about things like there were games written in Forth or Modula or stuff like this, but games were written in things that were as low level or lower level than C++ throughout all of history. And so really, it's only very recently that things like C# or Java have been languages that anyone would consider writing a game in. And the only reason that they can do that now is basically for one of 2 reasons. One, because they don't really have much in the way of serious performance requirements, which is often the case. Or 2, because most of the game is actually still written in C++ and they're just writing the part that sits on top of that. So for example, anyone who writes a game in Unity, well, a lot of the Unity engine is written in C++. It's only the part that's your game that's like the script stuff that's written in C#, right? And so since on Handmade Hero we're showing how to write the whole thing, engine included, obviously we would not be using something like C# or Java. That would just not be a smart choice at all. So really C++ is kind of the only choice, I would say. If you actually want to write a high-performance engine, it's pretty much the only thing that you really have at the moment, unless you were going to use straight C, which is, again, we kind of are mostly, but we use some C++ features, so we're almost kind of going that way. Or you go assembly language / some other kind of D maybe or something like that. But C++ is not a surprising choice. I feel like if you asked any game programmer in the industry at random, what would you start programming a game in right now? They'd probably say C++. It's not a strange choice. I think it's only strange to people who aren't maybe professional game programmers. I'm not sure. But I get that question a lot, and it's always surprising me because it's like, yo, man, all games are programmed in C++. Last question. Let's see here. I thought there was one other one on here that I was going to answer. Maybe I've got everything. Maybe I got all the questions. I think I did. I guess I'll just, as an addendum to that, answer one other question I see here, which is, would there have been an easier language to program the game in? And yes, there probably would have been an easier language to program the game in if you didn't want to do the engine, and you didn't want to do some of the more advanced game design stuff that we're going to be doing. I could have scaled the game down. Like, let's say we just wanted to make Legend of Zelda. That's it. It's literally Legend of Zelda. We could easily have done that in like XNA or Python Pygame, right? And largely the reason that would have been easier is not because the language is any easier. The languages really aren't any easier. The main reason it would have been easier is because there's giant libraries that do everything for you, right? So if we just decided not to write the engine and not to write and to just use a ton of libraries, then there would have been easier. C++ is not a great language for libraries. Like, the libraries that are available for C++ don't tend to be as complete, I find, as some other things. So, you could go use XNA and it'd be easier because if you weren't trying to write an engine, you just use the engine that exists. Or you could go use Unity and something like that. So if easy is all you care about and performance isn't super important and special considerations for a bunch of game design things isn't important, et cetera, then you can definitely go with something easier. And basically what that boils down to is it's less about the language, it's more about the libraries at that point. It's about finding something that has all the libraries that do what you want. And like, as another obvious statement, let's say you were going to make a first-person shooter. So you kind of just pretty much know what you're dealing with exactly. You could go use the Unreal Engine, and it's going to be able to handle a first-person shooter, right? It's a professional code base that's shipped multiple first-person shooters before. You just use it, and off you go, right? So things like that, if you're just looking for easy, there's definitely ways that you can do things that are designed for you to do the least amount of work. Those would be different options, certainly. All right. I think that's about it. I'm gonna call it. It's getting a little late here, and I will say answer two more quickies here, which is to be able to surpass C++ as the de facto language to code games. And what would you have to do as a language that would make you better than C++? Just go watch John Blow's stream. John Blow is making a language that's better than C++ right now, and it probably already is pretty much better than C++ right now because C++ really hasn't advanced in about 30 years. It's pretty much as bad as C. C was a good language for its time, but C++ really hasn't added anything of value for the most part. John has been adding a lot of things of value to his language, and so I suspect that the answer to your question is go watch John's stream, and he will show you exactly all of the things you can add that makes a language better than C for coding games. And then I'll also say to the person who asked if they can have a witness beta key, I am not in charge of giving out witness beta keys. You will have to ask John. All right, so that's it. And let's go ahead and wrap it up for the day. Let us close down like so. Close, and minimize. All right, thank you everyone for joining me for another episode of Handmade Hero. It has been a pleasure coding with you as always. I will be back here tomorrow night, same place, same time, 8 p.m. Pacific Standard Time on Twitch, where I will be going ahead and doing some, I guess basically we'll be having these guys fight. So I guess the monster and the hero with his new sword, will be able to attack each other and then kill each other, I guess. we'll go ahead and implement that tomorrow, and continue on our path towards getting everything nailed down for exactly what we need the engine to do. And I think that's pretty good. It seems to be coming along well, in my opinion. I think everything is going roughly the way that I want it to. So I'm pretty happy about it, and I hope you are too. If you would like to follow along at home and do experimenting on your own and that sort of stuff, you can always pre-order Handmade Hero, and it comes with all the source code that you can play around with. And of course, all the videos from past days are all available as well, so you can see how to set it up and how to use it by watching those as well. If you want to do that, you can go to handmadehero.org and hit that pre-order button. That'll do that for you. If you want to support the video series, we also have a Patreon you can subscribe to. We've got a schedule bot that you can follow on Twitter if you do this tweets thing. You can follow that bot, and it's got like the schedule tweeted every day, so you know what time the stream is. And we also have a news and forum site that I highly recommend going to. We're trying to overhaul it a little bit, do some more stuff up there. I've been working on that a little bit lately to kind of get it out of the web nightmare that is Joomla. But if you go there, it's got stuff like a discussion board, so you can post questions and ask, discuss things with fellow developers who follow the series. It's got resources, so if you want to follow along on like Mac or Linux, which are platforms we haven't ported to yet, there are people in the community who have already done those ports that you can piggyback on. You can go see how they did it. You can download their source code. They've oftentimes posted it for free, so you can go take a look at that. And it's also got an episode guide that you can use to catch up on past episodes. It's a lot better than using YouTube directly for the ones that people have annotated. So I'd highly recommend checking that out. So yeah, hope to see you here tomorrow night. Same time, same place. Have a wonderful Tuesday, and I will see you then. Take it easy, everyone.